Hello everyone, this is Satvik, and today we'll be solving the lab sheet 7, which is based on arrays. So let's talk a bit about arrays. Arrays are data structures which store a collection of similar data type entries. Like we can create an array of integers of size, let's say 10. Then we have a collection of 10 integers stored side by side in the memory. So let's see what we have to do in the first function. For the first function, we have to take in a float array and then compute the maximum element, second maximum element, minimum element, and second minimum element. And finally, return the average of the four elements. So let's start to code this up. As usual, first we will include the header file, then start writing the main function. In the main function, what we have to do is we'll declare the float array. The array is of type float and the size of the array is 10. Then we'll ask the user for input. So let's iterate 10 times and ask the user for input. Let's say the variable is num and we take in num as the input and store it inside the array. Yeah. So we have taken in the input. Now let's see how we can calculate the maximum, second maximum, minimum, and second minimum. So an easy way to do that will be to sort the array. The maximum element will be at the end, minimum at the beginning. Second max will be the element second to the maximum element, and the second smallest element will be the element at the index 1. So for sorting, we'll use a technique known as selection sort. So what we'll do is, let's say you have an array like 1, 2, 3, 4, 5. So what we do in selection sort is that we iterate through all the elements and start decreasing the window one by one. So upon the first iteration, we'll find the largest element or smallest element if you want. But let's say we'll start with the largest element. The largest element is 5. So we'll swap 5 with 1. Now the array becomes 5, 2, 3, 4, 1. Now this element is fixed. The maximum element should come at the beginning. So this is fixed. Now we want to sort the remaining portion. So on the remaining portion again, we'll do the same thing. Iterate and find the largest element and put it at the beginning of this portion. So the largest element is 4. We swap 2 and 4. So now the array becomes 3, 2, 1. Now we have this array. Now this array maximum element is 3, which is already at the correct position. So we don't need to swap anything. Or if we swap, the element will remain at the same position. Then we'll have 2 and 1. Again, the maximum element is 2, which is at the correct position. Then we finally have 1, which is again at the correct position. So this way, the array becomes sorted in descending order. So you'll also see this in the second question. So I'll explain it here itself, and then I'll give a brief intro about that in the second question. So for that, let's create the selection sort function. It takes in an array and the length. Then as said, I iterate through all the elements, length, and let's say I stored the maximum index in a variable called max. And then I'll again run a for loop starting from the index I plus 1 because I want to compare all elements starting from the index I plus 1 with to find the maximum element. So Here I'll check if array of j is greater than array of max. That means this element is greater than the element which I have stored in max. So I'll update max to j then. So at the end, I'll finally have the index which contains the maximum element from I plus 1 to length. Now I want to swap this with the element which is at the ith index because I want to place the maximum element at the starting. Also, I'll pass this by reference because I want to make changes to the actual memory location. So I'll create a function swap, take in as input x and y. Then I'll create a temporary variable. Also, these are float, not integers. Sorry, so this is also float. This will also be float. And rest all is fine because indices will be integers only. Then I'll create a temporary variable which will be used for swapping, store the value of x inside it, then assign the value of y to x, and then finally assign the value of temp to y. So this way I would have achieved the swap functionality, and I'm using pass by reference technique here. So after this, I'll just call this selection sort function with the array and the size, and I'll get the max element at index 0 because I have sorted it in descending order. So in a similar way, I can find the other elements too. Second max will be at index 1. Min element will be at the last index, which is 9. And second min element will be at index 8. Also, these are floats. So format specifiers will be F and not D. And finally, I also have to print the average. So average will be the sum of all these divided by 4. So let's do that quickly by 4. And then finally print the average also. Yeah. So I think this should work. Now let's save and try to run this. GCC shin1.c. Okay. So this is array of j. Okay. So I wanted to swap with max, not j, because I had stored the index of the maximum element in max. Let's try to compile this again. Yeah. Now let's try to run this. Let's say we take in input as 2.3, 3.2, 23.2, 121.1, 0.2, 6.3, 8.7, 3.4, 9.7, 9.4. Yeah, so as you can see, the maximum element is this. Second max element is this. Minimum element is this. And the second minimum element is this. Please ignore the spelling mistakes. And the average, you can find out the average as the sum of all these divided by 4. Yeah, so this was the first question. Okay, so let's continue with question number 2. So we have to make a program named search and sort.c, and it should contain the following functionalities: a function for linear search, another function for binary search, a function for selection sort, and then the main function as usual. So let's start coding this up. Again, I'm using Sublime Text and Ubuntu Terminal. So let's create a new file, save it as search and sort.c. Let's include the header files first. Then let's create the main function. So first, let's start building up the linear search function. So this function, its return type is int, and it should take in an array as a parameter and the element to be searched, which is x. So in linear search, we linearly iterate through all of the elements in the array and just check if the element which we are searching for is present in the array or not. Also, we'll have to take the size here also, because you don't have any function to calculate the size within linear search. So we'll iterate through all the elements here, then check if array of I is equal to x, then we have to return the index I. And if this thing doesn't happen, then we have to return -1. So what this basically does is that it iterates through all of the elements in the array, and if a match is found, then it returns the index I. Otherwise, the match is not found, then the loop terminates and then it returns -1 because the element wasn't found here. Now let's build the binary search function. Again, it takes in the array as the parameter, the element to be searched, and the length of the array. So what we do in binary search is that we maintain a low pointer which points at the beginning of the array. So 0 is the starting index of the array, and a high pointer which points at the end of the array. So it is at the position length -1. And now we write a while loop for the condition while low is less than equal to high. Inside it, we calculate mid, which is equal to low plus high by 2. If the element at this position is equal to the element which we are searching, then we'll just return x. Okay. Otherwise, if the array of mid is greater than x, then what we will do? We'll make high is equal to mid -1. Else, we will make low is equal to mid plus 1. And finally return -1. So what we are doing here is we are seeing the array between the low and high pointers. So mid is the middle element here because I have calculated the mean here. So if the middle element is equal to the element which we are searching for, then just return that particular element. Also to point out that the array which you are passing here must be sorted for binary search to work. So since the array is sorted, if the element at mid position is greater than x, what that means is that we want to search the element within the range low to mid -1. Low to mid -1. Because we know that mid is greater than x. So there is no point in searching for the indices above mid. So we'll search from low to mid -1. And if array of mid is less than x, then we'll search from low plus 1 to high. This is because we know that the mid position, the element at the mid position is less than x. So there's no point in searching for the indices below mid because they will be smaller than mid. Remember, I told you that the array here is sorted. So we'll search for the elements from indices low plus 1 to high because these are the only indices where the elements are greater than area of mid. So we'll search at these indices only. And then finally return -1 if we don't find our element. So this was the binary search function. Now we have to make a function for selection sort. So let's make that function selection sort decreasing. It will again take in the array and the length. So what we do in selection sort is that in every traversal, we calculate the maximum element and we place it at the starting of the array. That means suppose I have an input of the form 1, 2, 3, 4, 5. Then what I'll do is that on the first iteration, I'll find out that 5 is the maximum element. Then I'll swap 5 and 1. Then it will give me 5, 2, 3, 4, 1. Then I know that this is the maximum element. Now I'll start reversing from this index. Again, I'll calculate the maximum element. It is 4. So I'll swap 4 and 2. So our array becomes this now. Now we'll start from this index. Here the maximum element is 3. So we don't need to swap anything from 3 as 3 is already at the correct position. Then we'll start from 2, again 2 is at the correct position. Then we'll start from 1, which is again at the correct position. So this is how this algorithm works. So for this, we'll run an array from 0 to length. Then I'll keep a max variable for the maximum index. And then I'll iterate from I plus 1 to the length of the array and check if array of max or rather array of j is greater than array of max. Then means I'll update max to j. And at the last, I'll swap array of I with array of max. So what we are doing here is first we'll traverse through the array, find the maximum element, and place it at the beginning of the array. Then our I will move to the first index. Then we'll traverse from 1 to the last element. Then again we'll calculate the maximum element and place it at the first index. Then we'll start from 2 to the length. Again calculate the maximum index and place it at the index 2. Then 3 to length and so on. So this way we'll get the array in reverse descending order or descending order. So we'll also have to make a function for swap. So here I'll pass the parameters by reference because I want the actual locations to be changed. So if I just in the previous videos, you would have seen that if I just pass array of I and array of max, then the value swapped will be just reflected inside this function only. And when I get out of this function, the values are the same. But I want the values to change at their locations. So that is why I'm passing the parameters by reference here. So I'll take in the parameters int star x and int star y. Then for swapping, I make a temporary variable. Then assign the value of y to x and then assign the value stored in temp to y. So doing this will help me do the swap functionality. So our selection sort is also done. Now we just have to make the main function and give the user all the possible inputs which he wants. So let's make a while loop because we want to run it infinitely unless the user enters the exit option, and we want to give the user several functionalities. So let's start by enter 1 for linear search, and let's copy this. So it didn't get copy. Yeah, so 2 2 is for binary search, 3 is for selection sort, and finally 4 is for simply exiting. So we will take in the option which the user enters. For that, I'm using the variable n, and then I'll use switch case to handle different cases. So case 1 is for linear search. Okay. So for linear search, I'll ask the user to enter the elements of the array, enter the array of size 10, and then a line change. Also, let's declare the array here itself. The size of the array will be 10. X will be the element to be searched, and result will be the index which I'm calculating in the linear search and binary search functions where the element is stored. So let's take in the array as an input from the user. For that, we'll run a loop, and let's say the variable is named num. We'll take num as the input and then store it at index I. All right. Then we'll ask the user to enter the element to be searched. The element was X, so let's scan X. I already declared it at the top. And let's store the result in the result variable, and in the linear search function, what parameters I had to pass? Array, X, and length. So array, X, and the length is 10. Then if the result is -1, that means my element was not found. As you can see, if the element is found, I'm returning the index there itself. And if it is not found, then it will reach to the end of this function and it will run -1. So if the result is -1, then we'll print out element not found. If the result is not -1, that means that we had found our element found at this index. Yeah. Also, don't forget putting the break statement. Otherwise, you'll go through all the cases instead of the case which you actually want to go into. So for the second case, also we want these things to be present here. The only change will be that I want to call the binary search function instead of the linear search function. So just change this. Then for case 3, again I want the user to input the array. So this thing will again remain the same. And then I'll have to call the selection sort function, which takes in the array and the length. I suppose let's check once. Array and the length, yeah. Then I have to print it in the descending order first. So let's print it in the descending order, which is the natural order in which we have sorted. So just iterate through all the elements. I is less than 10, I plus plus, and printf the element giving spaces, and then just do a line change to ensure clarity. Then we have to print the elements in the increasing order also. For that, we just have to print the elements in the reverse order because the reverse of ascending is descending. So we'll start from the back of the array, go till the index 0, and print the elements in a similar fashion. Yeah, also then let's do a line change again to ensure clarity. And then we just break off. And if the case is 4, then we just want to exit from this while loop. So we'll do break, but this break will not ensure exiting from the while loop. This is just for a switch block. So let me create a flag here. If this flag is 1, till the time the flag is 1, this while loop will continue running. And in this case 4, I'll set this flag to 0. So now, when after the execution of this switch block, the control goes to while again, then the flag would have become 0 and the while loop will terminate. And also let's print by search and sort. So I think this should work now. Let's save it and try compiling and running this. Code is a bit long, but don't worry. Approach in a step-to-step fashion. Let's compile this. The name of the file is search and sort .c. Compiled successfully. Now just run the a.out file. Let's check for linear search first. The array, let's suppose it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8, 9, 10. Let's search for 6. So the element is found at the index 5 because it is a 0 based indexing. So 1 is 0, 2 is 1, 1 is at index 0, 2 is at 1, so 6 is at index 5. So I should have done a line change here for clarity. Let me do that. This was linear search. Yeah, so I forgot to do a line change here. Let's compile this again. First exit. Yeah, so let's do the linear search thing again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's search for 6 again. 6 is at index 5. Now let's try the binary search thing. For this, we need the array in sorted order. So we have to pass some sorted thing. 10. How many elements? 6, 7, 8, 9, 10. Okay. Let's search for, let's say 12. So 12 is not there. So let's see what is the output. Element not found. Let's check for. Oh, okay. So here, I think something is wrong. Yeah, so because I forgot putting the break statement after case 2, so because of that, it automatically jumped into case 3. And see, this thing comes from case 3. So don't forget putting this break statement, otherwise it will be difficult for you to debug. Now let's try running this again. The binary search function. We'll check for binary search again. 1, 2, 3, 4, 5, 6, 8, 9, 11. These are 9 elements, so 15. Let's search for 8. Yeah, so this time I'm getting this index. Also, yeah, so here I had returned the element itself. I had to return the index. So that is why the you can see that this is the element, not the index. So we'll have to recompile this again. Again, let's do binary search. 1, 4, 7, 9, 11, 13, 14, 15, 16, 18. How many elements? 6, 9, 10. Yeah. Let's search for 16. The index should be 9 this time. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So it is 8 because it is 0 based. 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 is the last index. So the index found is correct. Now the only thing left is selection sort. Let's give it the same input only. 1, 4, 7, 9, 11, 13, 15, 16, 18. Okay. So there was some other issue this time, I think. Let's see what the issue is. 11, 13, 16, 18. 1, 4, 7, 11, 13. Okay. So the number of elements were not 10 and I had taken in 10 elements. Yeah. So keep in mind to put the correct number of elements. And this is the descending order and this is the ascending order. Now just let's exit from this program and it gives bye bye search and sort as the output. So this was the second question.